Okay. So we've covered like a lot of the basic stuff and the stuff that you really need to know in order to use NumPy. But I do want to cover a couple other kind of specifics. So first off, you can have Boolean arrays. So instead of these types of arrays storing a number, they store logical true and false Booleans, right? So here I'm basically creating one of those from a list of Boolean values, and then I'm reshaping it into a two-dimensional array or matrix, and here I'm just printing those out. And you can see they print out as Booleans as opposed to as values or numbers. Okay. Then you can also get back Boolean arrays as the result of an operation. So here, what I'm doing is I'm creating some random integers between 0, 1, and 1200. I'm creating 100 of them specifically. I'm reshaping those into a 10 by 10 array or matrix. And then I'm creating a Boolean array by basically testing to see what values are greater than 150. Right. So if this evaluates the true, it'll return true, and if it in the array at that position, and then false if it's 150 or lower. So there we go. And you can see, so this is higher than 150, true. Let's go down here, higher than 150, true. Lower than 150, false. Right. So basically, it does that test on each element in the entire array across all the dimensions, and returns back an array of the same shape as the input, but now with the result of the logic. Okay, so this is some quick examples with Boolean arrays. So you can make them. They're also common output from tests and whatnot, logical tests. Okay, we talked about this early on, and when we started talking about Python. So if you have an object that's mutable, like a list, then if you just set another variable equal to that variable, you're actually not making a copy of it. You are just referencing it. So you have two variables that reference the same data in memory. And NumPy basically works the same way. So if you want to make a copy of a NumPy array that copies the data into another location in memory and doesn't just reference the same data in memory using a different variable, you want to use the .copy method. In contrast, .view basically will reference the same data. So for example, you can do a view of an array and then kind of change the shape of it. So it's just representing that same set of values in a different shape, whereas copy is actually going to copy it. So let's just look through this code real quick and have a look at the output. And note I'm getting this copy method from the copy library or module, so I'm having to import that. Okay, so yeah, there we go. Let's see here. 25. Oh yeah, that's right. So basically here what I'm doing is I'm creating 3 arrays, and they all have 25 elements. And by default that means that they're going to just there'll be vectors with 25 elements in them. And then I basically fill that up with values, and then reshape it so that it's 5 by 5. And then the array 2 is basically just a view of array 1, and then array 3 is a copy of array 1. And then I do this subsetting of array 1, and then to see how that affects other stuff. Okay, so basically what happens here, if you run through this, let me see. I guess I really wouldn't. Oh yeah. Okay. So anyway, here's my original array, array 1. Again, if you run this, you'll get different values because it's the random generator there. And then that was this print statement here. And then what I do is I take array 1 and I just convert all the values to zeros. So this is a colon, so that means everything in that dimension, and another colon, so everything in that dimension. So it's 5 by 5, so all the values get turned into 0. So now if I print R1, we can see that it's just a bunch of zeros. And then R2, which was defined as a view of R1 above, is also a bunch of zeros, even though it wasn't changed. And actually it was changed because, again, these two, R1 and R2, reference the same data in memory because we use view instead of copy. And in contrast, the copy did not get altered by this operation because it's data in a different location in memory. So again, this is something you have to be careful with, similar to like working with lists. Just simply setting a variable equal to another variable doesn't mean that you've got new data. If you want to make sure, you can use copy or deep copy or whatnot. Okay. Not sure that I need to run that. I think I just duplicated that. So, did I change anything? I just want to make sure I didn't have anything there that needed changed. Yeah, I think it's good. Okay, so oh, I remember. I went through each of these as examples. Okay, so to finish up here, this is just some simple arithmetic applied to arrays. So again, you have a lot of your mathematical operators are the same as they are, in like base Python. So again, here I'm just creating an array of random integers between 1 and 1200, and specifically I'm getting 25 of them, and then I reshape them into a matrix, 5 by 5 matrix. So when you do mathematics on an array, it's basically going to do it on an element by element basis. So here we are just adding 21 to each value, subtracting 52 from each value, multiplying each value by 2, dividing each value by 3, and then squaring each value, so exponentiation, right? So if we run that, there we go. Note when you get this message, it just means it stopped printing because there was just too much to print. But we don't really need to look at each of these. But like for example, the first one, 812, and then it got converted to 833, so we just add 21 to it, right? So it basically does those calculations on an element by element basis. Okay, you can also perform mathematical operations on arrays that have the same shape. So in this example, we have basically I made two random arrays here, and then actually let's run this and see what we get. There we go. So we have just the same array here. We add it to itself or subtract it from itself. When we subtract it from itself, everything is 0. When we add to self, it doubles the values, right? So the key thing here is when you have arrays of the same shape, it's going to perform that operation and it's going to match up the values so that they have the same index. So, for example, the first value in the first of all the indexes of the first array will be added, for example, to the value in the first index of all the dimensions of the second array, and so on and so forth. So you can think of them as like cells that stack on top of each other, and the operations occur like over those stack of cell values that occur at the same positions within the array. Now, whenever you have shapes that are different, sometimes this will work, sometimes it won't. There are rules for broadcasting and whatnot. Again, we're not going to get into that here in this kind of introductory section. Okay, so let's see here. What are we doing? So here we're making. Let me see here. Run this and take a look at it. Alright, so this is an example, another example here. So we're creating some integers between 1 and 100, specifically 36 integers. We're converting it into a array of size 6 by 6. And then I'm creating an array of ones in one dimension, or 6 ones as a vector, right? And then what I do is I multiply those together, and sorry, then I convert that array of ones into array of twos. So, and then I multiply it here. So basically what that does, if you look at the values, is it still does it for each value. And this is kind of how like broadcasting works. So because they have the same length in the second dimension, or I'm sorry, well, yeah, they have the same length actually in both dimensions, even though this is just one dimension, this is 2 dimension. Effectively what this is doing is treating this like it's 2's in a 6x6 array as opposed to just a vector of 6 values, so that it can match everything up. Now if we had something that was a different length, let's see if that works. So I'm going to put in 5 here and see what happens. Yeah, so here we got an error. Operand could not be broadcast together with shape 6, 6, and then 5. So it couldn't figure out how to reshape the 5 2's to basically to multiply it by the 6x6 array. Now, if we did something like 3, I believe that'll work. Yeah. Nope, actually no, it didn't. I guess that didn't work either. I guess, yeah, we have to have a dimension that matches. So, again, if we have 6, it'll work, but it didn't work for 5 because it couldn't match everything up. So there's a lot to the broadcasting. Again, we're not going to get into that in detail. I just kind of wanted to mention it here. And this is a similar example. Oh, sorry, actually this is different. So this is just showing a couple mathematical operations that are provided as NumPy functions. So max, min, square root. So if we run this, basically max returns the highest value in the array, min returns the lowest value in the array, and then this returns the square root of each of the values in the array. Okay, so that's an introduction to NumPy. I hope you found this useful and interesting. Again, since we're dealing with numbers, this is super important. A lot of the other libraries that allow for data science in Python, like Pandas and SciPy and scikit-learn, sit on top of NumPy. And even more recently, so like with the development of deep learning, there's been adaptations of this tool that's been generated to allow for using arrays on like GPUs and stuff, and that's the whole concept of like tensors, which is a big thing in deep learning, but it actually shares a lot of the same characteristics and whatnot as arrays. Okay, so in the next section, we're going to look at pandas, as a means to work with and use data tables.